Like we discussed that there must be the gases, different gases which diffuses at different rates, like you are seeing here. Let's see. The thing is like we have the two cotton wools, as I have said, that the cotton wool which contains the hydrochloric acid in it. There is another cotton wool which contains the considered ammonia solution. And we just put them in a tube and we just put some barrier for them like the core. And we just put them apart from each other. After some time, we'll see a white ring forms. What does this white ring means? Because this thing like here the hydrochloric acid is just moving, and from here the ammonia is moving.
Writing like is the product which forms
That
when the
is
two.
basically the ammonium chloride. That's good. White cloud is basically, white ring is basically the product we have got by the experiment of the ammonia and the hydrochloric acid. By this diagram, I'll ask you a simple question. Which substance is more able to diffuse? The substance is more diffusible, ammonia or hydrochloric acid?
Ammonia because it lament like the fastest.
That's good because it covers most of the distance in the tube, and the hydrochloric acid in a gaseous form, it just completed very few part of a distance. But if I give you the idea, so why there is a question must be the students ask always that why we are discussing about the diffusion gases, not in the liquids, not in the solids. Do you have any answer for that, Amma? Why we are
Because like
discussing
diffusion mostly happens in gases.
diffusion mostly occur in gases because the rate of diffusion of gases is very much high as compared to the solids and liquid, because
Yes.
as we have wrote in
Ice.
the first point. Okay, so if I just give you another idea that if you haven't have a diagram, if you'll not get a diagram in your exam, how can you identify that which gas diffuses more faster than the other?
Based like on their no like will they give anything like any hint or something? Yes, according to the mass.
Molar
Like
mass. We say the molecular mass, we must say the molar mass of that thing.
yes.
Molecular mass or molar mass, they are but somehow similar to each other. If I just put the G in sense of unit, it will become the molar mass. And if I just put the AMU, it will become the molecular mass for any of the substance. Okay, so the thing is that there are the two types, rate of diffusion of any gas is inversely proportional to the MR of gas. Yeah. Rate of diffusion of any gas is inversely
Yes.
proportional to the MR of gas. If I say that we have ammonia like NH3 and we have HCl, what will be the MR for ammonia?
It will be like less than the HCl.
What it is? It's a very good answer. It's less than the HCl. I'm asking about the number. You know that nitrogen has atomic mass which is 14. Hydrogen has 1. So 1 hydrogen is 1 and the 3 hydrogen will become 3. 14 plus 3, it will become 17. And HCl, 1 hydrogen is 1 and 1 chlorine is 35.5. So it will become the 36.5. Which substance has more MR?
Hydrochloric acid.
So if a substance has more MR than other, its rate of diffusion is less than the other. If a substance has less MR than other, has more rate of diffusion. If a substance has high MR, it means that less rate of diffusion. Is this is clear?
Yes.
What happens when the diffusion occurs?
Like they move from higher area to lower. It means evenly spread in the area.
According to the KPT, how can you explain?
Okay, so according to the means the molecules start moving faster because when the temperature is rising, they start moving faster and spread evenly across the area.
Does diffusion process depends on temperature? Seriously? Seriously? Is there any concern of temperature in the process of diffusion? If I'm just spraying gas, if I'm just spraying a room spray in my room, does this thing requires a high temperature or low temperature or the temperature change for spreading into my room?
No.
How
Means it
can you
can
say?
also be controlled temperature, but temperature like it can affect the rate at which the diffusion happens.
The temperature affects the rate of diffusion, but temperature has eventually no basic concern for the spreading of a substance. Spreading of substance occurs due to the, why we are saying that the gases have the very high rate of diffusion. We can study gases in the sense of diffusion process. The reason is this.
This is because they can move faster and they have less force of attraction.
They have large intermolecular distance. They can move faster. If I say that we are sitting in a class and everyone is sitting in a row, now there are the three rows, one, two, three. There are the three rows, and each row contains the four chairs, and everyone sitting in this in a line, and every seat is just occupied, and there is only one seat left. How many of the students can be adjusted in this class?
And can you please repeat?
If I say that I have a class and in my class there are the three rows of chairs and every row contains four chairs and every chair is occupied, there is only one chair is empty. So I am asking you a question that how many of the students are able to adjust in this class?
Means there will be like for 3 years. If there will be 11 students, then there will be one chair left.
If there is only one chair left, so how many of the students will be able
11.
to adjust? 2, 3, 4, 1. How many?
No, if it is, then there will be total 11 students, so they cannot evenly adjust.
How can they be? How many of the students can adjust in the one chair?
Only one.
Only one. If there will be the two empty chairs, how many students will be adjust?
Okay, two.
So, on which thing the adjustment depends?
On the number of chairs.
The emptiness of the chairs. Okay.
Yes.
So the thing is, the diffusion also depends on the intermolecular distance. If the intermolecular distance is large, so the diffusion can occur very easily. Okay. If the intermolecular distance is very low, so the diffusion occurs at very low speed or diffusion happens at very low rate. Okay. As you said that the gases are very large, they move very fast. So the movement also helps in the rate of diffusion. Movement also helps in the rate of diffusion. That is why we are discussing about the diffusion in gases, because the gases have very large intermolecular distance as well as they have large speed. They can move very fast in the medium. As this
So
is
there,
clear?
yes, so there's any effect of pressure on diffusion, or it
There
is
must be
only
there will be an effect of pressure. There will be an effect. If I consider a very simple system here, and there is no temperature, there is no pressure, but there is a very simple
room temperature.
standard temperature and standard pressure here. Na? In this standard temperature and pressure, we are doing the diffusion. So diffusion occurs very normally. But if we want to diffuse the substance very fast, we can involve temperature in it. We can involve pressure in it. You know that when we are just filling the gas tire, when we are just pouring the air into the gas tire, how we will do? We are just pressuring the air into the tire, na? We are just
Yes.
pushing the air into the tire. If we are not pushing the air, if the pump which is if the cylinder we have which contains air, it doesn't have a pump, pressure pump. So do you really think that the gas can go into the tire and fill it?
Yes, it may take a lot of time.
It may take a lot of time. But when we are pushing it with the pressure pump, it happens in a second, in a blink of an eye. Is this clear? So the pressure has an effect. The pressure has an effect. Is this clear?
Yes.
Okay. So how can the temperature affect in the diffusion? Do you have any example? Do you have any idea that how the temperature affects? Let me give you the idea. There is a very simple phenomenon of this. After the class, after you when you get the free time, do an experiment, then you'll see that how the diffusion occurs, how the temperature affects the diffusion. Na? Get a glass of water, a very chilled glass of water, the water which is nearly become ice. Get that glass of water, na? And put the glass on the table. Put the place in front. Put your phone in front of the glass and start the video. And drop a very small amount of ink drop into the water. Capture this whole process in the video, and after dropping the ink into the glass of water, you'll see that in a minute or less than minute or more than minute, the ink will be just completely spread into the glass of water. Okay, now do the same experiment with the warm or lukewarm water. What do you think? In which water the ink spread faster?
Chilled water.
That's good. The high temperature water, the more temperature water, the heated water, the phenomena is like the molecules are in very much energy. The molecules are very much energetic. They are just pushing the coming molecules towards one direction, the other direction, and they are just completing, spreading into the whole medium.
It will be fast in the colder water, right? ये क्या हुआ है?
That's good. It will be very much fast. No, it never happens in the colder water, because the reason is in the cold water, the molecules are just cozy with each other. They are just coming close to each other, and the molecules are not moving very fast. You know that, when we increase the temperature, the molecules starts moving very fast. Is this
So
clear?
it will be faster in warm water than the chilled water.
That's good. It will be faster in the warm water than the chilled water. Okay. Is this clear?
Clear.
Okay. So we will be discussing, inshallah, Aziz, the other topic in our next class. Okay. तब तक अपना ख्याल रखिएगा। अस्सलाम वालेकुम।